Good afternoon, everyone. Thank you so much for joining us today for our webinar, Spanning Solutions with the Timber Bridge. My name is Cheyenne Stopford, and I'm the Sales and Marketing Coordinator at Yorkbridge Concepts. We're a full-service design build firm specializing in vehicular and pedestrian bridges focused on longevity, style, and craftsmanship. Our 8,000 plus bridges can be seen in almost all 50 states, as well as the Caribbean islands, Central America, and Europe. Today's presenter is going to be Titus Edwards. Hi, Titus. Thanks so much for joining us today.
Hello, Cheyenne. It's good to be with you today. Good to have all the people listening to us as well. I believe this is our fifth and final webinar this year and our third year for doing webinars. And we're excited to be with you again today.
Absolutely. Can you believe we've gone a whole year of doing webinars? Can't believe. Feel like this year has flown by.
It has. Hard to imagine.
Yes. For those of you who are just joining and don't know too much about Titus or Yorkbridge Concepts, Titus is our lead senior bridge consultant, and he has been with the company for 21 years. So I'm super excited for him to talk to us today, and hopefully we will get to learn a lot about spanning solutions. Now, I wanted to start off with a little bit of a trivia. What do you think are some spanning challenges that we face on the regular? And while you guys, I'll go ahead and open the chat so you guys can fill in some answers that you may think, and we'll get to those in a minute. But while you go ahead and fill out the chat, just wanted to talk about some little bit housekeeping things. So before I pass the mic to Titus, I wanted to point out some Zoom features that we'll be utilizing throughout the webinar. As for those of you who have used Zoom, I'm sure you're very familiar with it at this point. We have the chat feature and the Q&A. Just please note, if you ask a question, we will only get to those questions at the end of the webinar. All right, so let's go ahead and dive into some of the answers of the challenges. Titus, I'll go ahead and pass the mic to you.
Well, it's interesting, Cheyenne, that if you talk to developers, they will tell you that all the good land has already been built on. So whenever they're looking to develop, they're normally looking at land that has challenges. Now, when you're talking crossings and bridges, you're talking challenges, and there can be a multiplicity of them. There may be environmental restrictions, flood elevations, the flow of the water, the depth of the water. There may be a wetland involved, a floodway, a floodplain, stream boundaries, elevation changes, utility easements, and on they can go. And Cheyenne, even the budget of a client may sometimes be a challenge.
Absolutely. I would think, would that happen more often than none for budget restrictions?
You know, you'd be surprised at how many times it becomes a challenge as well. But fear not, there are solutions. And that's what we're going to be talking about today. Yorkbridge is a national design build timber bridge building company. In our 38 years, we built over 8,000 bridges all over the country. Now, what that means is we have come across, with all of that experience, almost any imaginable type of crossing. And we're able to come up with a solution for the crossing. And in so doing, we've come up with about 5 basic spanning designs that we utilize. And that's going to be what we want to talk about in our outline today. But we want to approach it from the standpoint of what the challenge was. We'll show you various pictures, how we overcame it, and why we use that type of design.
Well, I'm super excited to dive in. Let's go ahead and get started.
Well, the very first of the 5 spanning solutions we want to talk about is what we call a repetitive span design. And what we mean by that, Cheyenne, we're just simply taking short spans and repeating them through a crossing.
Now, Titus, can I ask, there's the difference between a 10-foot and a 15-foot span. Why the difference?
Well, there at the top is a typical pedestrian boardwalk or bridge, repetitive span. You can see the piling bench through the crossing, and those are 10 foot on center. But the one at the bottom is a vehicular bridge. And on vehicular bridges, we are able to span a little bit further, and we typically use 15-foot spans. It has to do, Cheyenne, with the efficiency of the size of the materials. I'm going to come back to that in just one second. There's another reason too, we'll come back to in just a moment as well. On the top, this is the Walsh Ranch project. It's a residential subdivision in Fort Worth, Texas. Over to the left, there's a new school that was built. Over to the right is the subdivision. And they had a floodplain in between that needed to cross. We resolved the problem by building this repetitive span boardwalk that allowed the children to be able to get to the school. The one at the bottom is a residential subdivision. It's the Esplanade Siesta Key project in Sarasota, Florida. This is a residential community Taylor Morrison built, and they had this wetland they needed to cross. The subdivision needed a rear access, road access, to allow people in and out of the subdivision and secondary access. So they needed to be able to get over this little wetland and stream area to get people out. And we built this 2-lane vehicular bridge. Again, you can see the piling bents 15-foot on center through the crossing. But the 10-foot and 15-foot, very efficient with the size of the material, the piling, the cap, and the stringers, because we are able to use all glue or all sawn dimensional lumber stringers. But Cheyenne, there's another reason.
What's that, Titus?
It has to do with the reach of our equipment. We have a time-lapse video coming up showing us building a vehicular bridge down in Southeast Florida. This is a Sunset Beach bridge. And notice how we're building it. We're using an excavator, and on the end of it is a compactor hammer. We reach out, drive our piling, and we can reach out about 15, 16 feet, drive our piling, and then we build a section and drive the equipment on it. Deck level construction. We're known for that. We can build a pedestrian bridge that way, smaller excavator. We can reach out 10 feet. Vehicular bridge, we can reach out about 15 feet. So that's the sweet spot, because it now allows us this deck level construction. And now you can access over water without any dewatering or using mats or barges. It's a very efficient way to build. And then the size of the material we're using works very well as well.
Very cool. You know, one thing I love about time lapses is it almost seems like this job was done within minutes, and I'm sure the the builders would definitely tell you otherwise.
It took them a little bit longer than 3 minutes to build it, but we do build very, very quickly as well. And we have some other examples of these repetitive span designs. This is the Delight Quarry Bridge in Reisterstown, Baltimore, Maryland area. Now, what's going on here is a Beazer home residential subdivision. They were developing part of it to the left. There was another section of land to the right, but they had to get over a stream and a wetland. And the way the civil engineer laid the roads out, they needed to come across. And we built this repetitive span design bridge to be able to accomplish that.
Absolutely beautiful bridge for sure.
Nice horizontal radius. It worked out very, very well. Another project we did is down in Southeast Florida. This is the Ave Maria University. Isn't that a beautiful bridge?
Oh, yes, it is. Can you tell us about the challenge with this one? What was the challenge here?
You can see it's a repetitive span design, and it's crossing over a lake. You had a university here existing, but on the other side of the lake, they had property, and they wanted to build a shrine and have it to be a gathering place for the students without them having to go all the way around the road. So we built from the deck of the bridge, this pedestrian repetitive span bridge over the lake with a piling bench 10 foot on center. It now allowed them that access so that the students could gather over there.
I definitely love this one. I'm gonna take a leap and say the challenge here for this apartment complex would make sure all the tenants were not swimming with the alligators to go swimming to the pool.
Very true. This is down in Florida. As a matter of fact, it's not far from our office, the Iris at North Point. It is an apartment complex. You can see, as all developments here in Florida have retention ponds. You can see the pool on the right. They wanted people to be able to walk over and get to the pool easy. And so we built a repetitive span pedestrian bridge Yes, you definitely don't want to be swimming across, getting involved with the alligators. And most all of our waterways have alligators in them.
Absolutely. Yeah, that's definitely one thing in Florida. You try to stay away from any body of water.
Indeed. So these repetitive span designs, they're the most efficient, most cost-effective way to design, build a bridge over a lake, a pond, a wetland, a waterway. But the key is where they will allow piling supports in the crossing, and it allows us to build these from the deck and to be able to access places that may be difficult otherwise.
Well, thank you so much for talking to us about repetitive. Can you go into detail about short span? Obviously, it being shorter, what would be the benefit of going with the short span design?
Well, short span design is the second type of span we want to talk about, and that's where you have a small crossing, but you don't want to put a bunch of piling through the crossing. So you're doing one short free span design a bridge. Sometimes it's either not logical or permitted to put supports in a crossing. The top is pedestrian, the bottom is vehicular bridge. 26-foot span that you see, this is in the Orlando area. And you can see what we're crossing here. By the way, Cheyenne, have you ever been to a pool complex and floated down the lazy river?
Yes, I have. And the one thing that I like is you don't have to pay attention to anything.
I could just imagine you with your wide brim cap on, looking very nice. This is a 26-foot free span, a very short span. It worked very, very well. Obviously, you're not going to put any supports in the middle of that lazy river. Now, what's going on there at the bottom is a 25-foot vehicular bridge, one single short span. And this is at the Baltimore School of Maryland. They had an existing school, but they had some land on the other side of Moore's Branch. That's that little creek that you can see there in the background. They wanted to build a soccer field, and they needed to be able to get vehicles and people over there. So we built this single lane vehicular bridge. You can see it's a very small creek. One short free span worked very, very efficiently.
These bridges are absolutely gorgeous, especially, and gives it more of a nature feel, even with the aesthetic of the bridge for that one. I like that one.
It does. And this is also very a cost-effective design to build because we're able to utilize up to 26 feet. These are normally 25, 26 feet range. Sawn dimensional lumber for the stringers, and that's very cost effective. Here's an example of these stringers that we're talking about to make the span. I believe this is the same one, the park school we just saw a picture of. Very cost efficient with these free spans up to 26 feet. Now, once we go over that, we'll talk what we have to do more in just a minute. Another bridge we built like that is up in North Carolina. This is our Meadowlands Bridge in Calabash, North Carolina.
Beautiful. Can you tell us about the challenge with this one in Meadowlands?
This is a residential subdivision. You can see there at the bottom, very brief, very slightly, there's a creek there. The developer had built out. He had one last section of land, but it was on the other side of a creek. He had to get over the creek, build a road to get the access and let people live over there. He didn't really want to use a culvert. He wanted something a little bit more aesthetic. And so we designed and built this 26-foot long, one single short span, timber, two-lane vehicular bridge. It worked well for the crossing, and it also worked well for the budget and the aesthetic intent the developer was looking for.
So just another happy client.
We love happy clients indeed.
Yes, we do.
And our last example along this line is Dove Landing. This is a Beazer Home residential subdivision up in Millville, Delaware.
Beautiful. So the challenge for this, I'm guessing we didn't want to go with a culvert alternative. So the short span was the one that was best for this circumstance, correct?
Correct. And they actually looked at a culvert initially. They wanted something, again, more aesthetic, that fit the crossing a little better. 23-foot long, single span. You can see again the sawn dimensional lumber stringers there at the bottom, one single span, but a 2-lane vehicular bridge crossing over this stream. It allowed them to be able to develop houses on the other side. So these short free span timber bridges work very effectively on short crossings where you don't want to put any supports in the middle.
Well, thanks for talking about the short span. We have 3 more left. What would be the free span, the benefit of free span bridges?
The short spans we talked about go up to 26 feet because of the sawn dimensional lumber stringers. But what happens if you have a longer crossing that you need to do a single span? Well, we do what we just simply call a free span using glue laminated beams. So the difference in the two, number one, the length, and number two, the beam. Instead of sawn dimensional lumber, we're now switching to use a glue laminated beam. These beams now allow us to span further, 40, 50, 60, 70, even up to 100 feet, one single span without any supports in the crossing. And they work very, very well for a number of reasons, and we'll talk to you about those and more in just a minute. This bridge, by the way, Cheyenne, is up in New Hampshire.
Wow, beautiful. I love it looks like it was almost taken in late summer, early fall. You see those leaves changing. Beautiful.
Yes, Bratton Woods, New Hampshire. This is behind the Mount Washington Resort Hotel. It's a 90-foot free span, 10-ton bridge, and you can see what's going on here. There's a beautiful sensitive stream. They're not going to allow any supports in that stream. And so we were able to do one single free span, and it made the crossing work very, very well.
Now, can you just talked to us about the glue laminated beams, how it's different than sawn dimensional lumber. What would, I guess, how are we able to get that sort of camber on that right there for the bridge? How are we able to do that effectively with the glue laminated beams?
You know, it's a good point that you make, Cheyenne. Sawn dimensional lumber, since it's being cut out of a tree, is straight. So you cannot have a horizontal or vertical radius. You can't have a curve or an arch. But glue lams are man-made beams, and most all of them have a camber to them. You can see an extreme example there to the right, but even the one on the left, by camber, we're talking about a slight arch to them, which is part of the structure of the glue laminated beam, but also gives a nice side profile to the bridge as well.
Well, it's definitely really interesting, the difference of those. And I believe we have a time lapse of the glue laminated stringers getting set.
Here we go. We built our timber abutments, and on top of those abutments, we have added the glue laminated stringers, and here you see we're setting those. And now you're going to see in just a moment the completed bridge, same one.
Ta-da!
Ta-da! There it is. It's the Atlantic Beach Country Club in the Jacksonville, Florida area. Now this is 55-foot long, free span bridge, and you can see on the side there we use the glue laminated beams on our timber abutments, 2-lane vehicular bridge for this golf course residential community. Now it's interesting what was going on here though, Cheyenne.
What's that?
Well, this waterway may look like very innocuous, but it was considered a wetland and a stream, and they were not allowed, because of the sensitive nature of it, to touch it. So they had to span over it, but they needed access to be able to build a new clubhouse. And this bridge allowed them to tie the road in and connect the new residences to the clubhouse.
Well, I think I've said all the past ones have been my favorite. I think this is my new favorite, just because it's beautiful. I love how it captures the color of that clubhouse in the background.
Yes, indeed. It worked out very, very nice. Well, where might we use some of these free span designs? We'll just show you some real quick. The one on the top left, you're crossing a very sensitive stream. This is Keystone College up in Pennsylvania. Existing school on the other side of the river. They had land and they wanted to build ball fields. This vehicular bridge allowed them that access. The one on the right, now we're back to Mount Washington Resort Hotel again in New Hampshire. This is the entrance bridge, 80-foot free span, very sensitive stream, but also a lot of velocity to this stream. Because of the velocity, you wouldn't want to put a lot of supports in the water. And then the one at the bottom, kind of hard to see what's going on there though, isn't it?
Yeah, it is. Looks like there's a massive, massive thing of trees down there.
Well, if I tell you where it is, you can probably guess too. This is in California.
Ah, okay. Yep.
A lot of environmental restrictions, especially in California. This is actually a very deep gorge or ravine. It was all protected, environmentally protected. They were not allowed to put culverts in or supports down in there. So we did one single free span, 77 foot long. And this is an apartment complex. Again, you're connecting different sections of the apartment complex to allow people to walk back and forth.
Very interesting. Now, can you tell us about the challenge with this bridge in Waynesboro, Virginia?
You know, this was a trail project, and they were building this trail right alongside the river. Beautiful place to walk and bike. But they had a little creek inlet that came across, dumping into the river, and the trail crossed it. So to continue the trail, they needed a bridge. In this case, they didn't want to put any supports in the crossing. So we did one single 40-foot long free span with glue laminated beams. And one final example is our Waterworks Park project down. This is not far from home, is it, Cheyenne?
No, it's not. I actually go on this bridge pretty often. It's one of my favorites locally to me.
Yes, and there to the left is the famous Eulalie's restaurant. If you ever get a chance, go there. If you ever come to Tampa, it's a great place to eat. But what was going on here? This whole area had overgrown, and they wanted to build a new park, which is off to the right. So they revitalized the spring that was there, cleaned it all out, and then the spring dumps down into the Hillsborough River. And we built two of these 35-foot free span bridges over the newly revitalized spring. So these free span bridges were now able to span further without any supports in the crossing. They're beautiful, and they work very, very well in these type of scenarios.
Absolutely. Which that leads us to our multiple span. Can you dive into a little bit about the multiple span versus free span and the short and repetitive?
You know, now we're really getting creative, Cheyenne. You're going to see this with the next two, which are variations of one another. By a multiple span bridge, all we simply mean, it's a hybrid of the first three designs, where you have repetitive span approaches and a free span section. Now, here's a couple of drawings. The top's pedestrian, the bottom's vehicular. And you're going to see both of these bridges actually completed in just a minute, pictures of them. But look what you have going on at the top. There in the middle, there is a 44-foot long free span with a glulam beam. But then notice, look left, look right. You see the piles, the short repetitive span approaches. That's what we mean. A single bridge, but it's made up of spans of different lengths. The one at the bottom, same thing.
Now it looks like on the bottom, there was an existing creek along with a existing utility easement. Was that one of the challenges we had to figure out how to implement this bridge?
Exactly. We're going to see more about this in just a moment, but there was a stream there in the middle, and there's also a utility easement, which meant a utility pipe was buried in the ground. So the bridge is 250 foot long, and we put an 80-foot free span in the middle over the creek and easement. And then we added our short repetitive span approaches. Now, this is very creative, but it's very effective and cost-efficient way for these longer type of crossings.
I believe we have an example of the town. There it is, Town Village. That's what we were talking about.
This is actually in Kennesaw, Georgia, north of Atlanta, at the town center at Cobb. It's a mall. By the way, Cheyenne, have you ever been to a mall?
You know, I feel like if I were to say no, my wallet would stare at me and laugh. So yes.
All women love malls, right? Well, there is a big mall right there to the left, but to the right, the developer had some land and he wanted to connect so he could build some apartments and other commercial and residential areas. But he had a problem. The problem was, well, there's a stream there. And right next to the stream we saw in the drawing, there's a sewer line and the sewer easement. And this is all considered a floodplain, but we resolved his problem by a multiple span design. You see the short span approaches, the 80-foot glue lam span over the sewer, over the creek, and then the pile supported on the other side. So multiple span design worked very, very well and very cost efficient for the client.
You can definitely see the creative aspect that went into that design for sure.
The one on the bottom, I love these covered bridges, Cheyenne.
Yes, beautiful.
This is Winyao Bay, another residential subdivision in Georgetown, South Carolina. This is the entrance road going in to allow people to get there, build houses to the subdivision, but they had a problem. And that was what looks to be a little pond is actually considered a wetland area. And they were limited in how much impact the Army Corps of Engineers would allow into that wetland. So here's what we did. You see there's two short spans right, two short spans left, but look in the middle. In the middle, there is a free span, 66-foot long free span. And because what happened is we reached the maximum number of impacts based on our piling that were driven into the wetland area. And therefore we had to be able to, we spanned that center portion to reduce the impact into the crossing.
Very cool. In terms of the Hampton Lake, the last one on the right, it looks like there was big enough we were able to do something big enough for a kayak or something to go through. Is that the case here?
Actually, they even had larger boats going under and through the bridge. This was a canal that connected lakes at Hampton Lake subdivision, a residential subdivision. And again, they needed a road to access other parts of the subdivision to develop. And this is a 60-foot long, 2-lane vehicular bridge. So you see the glue lam span over the water that allowed the boats to go through, but then we added two short approach spans. But there's something else going on here with the multiple span. Well, why didn't we just do one single long free span with a glue lam beam?
I'm going to go with, was it a cost thing?
Ding, 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 ding. You know, we saved that developer about $60,000 by doing the multiple span instead of the free span with the glue lams. The glue lams are great when you have to have them for the longer spans in sensitive areas, but they're more expensive because the glue lam beams are more expensive. But by marrying it with a couple of short spans, multiple span design, it helped bring the cost down. It worked. It made the crossing work. And it turned out to be a gorgeous bridge.
Absolutely. And just for time's sake, I'm just going to go through a couple of these examples if you want to touch on them briefly.
Sure. Champions View, another apartment complex, 20-foot span in the middle, two 10-foot approach spans to get people across to the pool area. Worked very well. And Esplanade Lake Club, love this, one of my favorite bridges. Residential subdivision off to the left. This is the entrance road coming in. So they had to get over this canal and connect the lakes, allow boat traffic. So we spanned over that section and added two small approach spans. And again, it met the design intent that they were looking for and kept it well within their budget. And again, what a beautiful looking bridge.
Absolutely beautiful. Yes.
And one final one. This is the drawing we saw to begin with, the Tarpon Point. There to the left is the Westin Hotel, and they built a convention center. To the right is a new parking lot. So they wanted to get people from the parking lot to the convention center. A bridge was needed across this waterway. Now, you can't really see what's going on here, Cheyenne, but this was a very sensitive environmental area. Plus the soils were really, really bad. They're like butter. You dry piling more than 100 feet to be able to find any bottom. So we wanted to limit the number of piling bents. So we did a multiple span design. You've got the 44-foot free span over the main water channel with the short free span or repetitive span approaches left and right. Turned out very nice.
Absolutely. And since we were just talking about multiple span, you mentioned that being the hybrid of the three. Can you talk to us about the multiple long span, how that differentiates?
Yeah, so multiple long span is very similar to the multiple span. The difference is there's no repetitive span approaches like you see at the top. You see all the short spans left and right. The one at the bottom is the multiple long spans. It just simply uses several longer spans. multiple long span design. Now, this is, again, very, very creative and used in a number of cases. And we're going to show you this one on the bottom and talk a little bit about it because it's a perfect example of where and why we might use something like that.
Now it looks like on, oh, I'm sorry. It looks like on the bottom, it's very unique that there's a sort of tilt or arch to this, to the support. Is that correct?
That's correct. There at the bottom, you can see that the piling bends, the bridge is skewed to the road or angled to the road. And we'll show you why we're doing that in just a moment. Up there at the top, you see what we'll go back just a second. You can see where there's a creek that we're crossing, and then to the right, a sewer line. There's a sewer easement. So that means a utility is there in the ground. But also look at the height. This bridge is almost 40 feet high. So you had height, you had creek, you had utility easement. Wow, you just had a lot going on.
You had all the things.
Yes, all at once. And here's the resolution.
Ta-da!
There you go. Isn't that a beautiful looking timber bridge? Now you can see the angle of the piling. We're angled the piling bends to be able to match the flow of the stream and the line of the sewer easement. What's going on here is up to the left was some land. Developer wanted to build an assisted living facility. This is called the Inspired Living in Alpharetta, Georgia. The road coming in, this is the entrance road. They needed a 2-lane road to get people up there. They had to cross this stream, and it's a floodplain. And Cheyenne, the engineers originally designed multiple culverts. But when they did, they did the HECRAS study, and they were going to raise the flood elevation 13 feet, which they would have never been allowed to do. We came in with this 3-span, multiple long span design bridge with the skewed bends. It worked perfectly. It is actually less expensive than the culverts. It met the client's budget, and look what they ended up with. What a beautiful bridge that solved all of their issues.
And again, another happy client.
Ta-da!
Ta-da!
So here you're seeing some of the issues: height, soil conditions, limitation to supports. All of these factors go into us coming up with our design recommendations. And sometimes these multiple long span bridges work very well.
Now, thank you for sharing that. For this example, was the challenge, it looks like almost a recreational complex in a neighborhood. You see all those trails. Was something here, it was also an environmentally sensitive area that we had to be careful of how we place this bridge?
Well, there was a lot going on here. This is the River Lights Master Plan Community in Wilmington, North Carolina, a Newland community at the time, right along the Cape Fear River. But this whole community was built basically upon people getting out and exercising and walking and biking. And we built hundreds and hundreds of feet of boardwalk and docks and piers. But this pedestrian bridge was kind of unique. You can see the sidewalk we're connecting over this body of water. But guess what? They wanted to go under the water or under the bridge.
Very cool. Yeah, we definitely didn't want them going underwater. Under the bridge, yes.
Kayaks and boats, mainly kayaks. Cool. They wanted to be able to go through and under the bridge, and therefore we designed it with multiple long spans. It's 120 feet, made up of 3 40-foot glue laminated beams for the stringers, and it worked very well. And again, what a beautiful design.
Absolutely. And just changing up environments here. Can you talk to us about this? It looks like it's at a shopping complex or a mall. Is that correct?
There we go. Another mall, the Uptown Village Mall in Cedar Hills, Texas. That's the Fort Worth, Dallas area. And you can kind of figure out what's going on. This is parking lot. They're connecting parking lots, but the parking lots were split by a drive. And this was a drive access where they brought deliveries into the mall. So we had to span over, and the multiple long span design worked very, very well. By the way, can you see the name?
I was just about to say that. That's something that just popped up to my eye. Very unique to this bridge. I love the fact that we were able to incorporate that.
Yes, that's very cool. The name is in that handrail design. Well, Cheyenne, we've seen a lot of beautiful bridge pictures today, and we've seen all different kinds of challenges and how we were able to overcome them by utilizing one of our 5 main spanning solutions. So we're able to solve almost any crossing challenge with one of our timber bridges, to come up with a creative design solution that will work for your budget, and then you're going to end up with a beautiful legacy design York timber bridge.
Well, Titus, thank you so much. Looks like we have a couple questions we're going to get to in a minute. We always appreciate you coming on and talking to us about everything regarding bridges and spanning solutions and challenges. We did want to let you know, for all who have attended today, we have additional resources available on our website if you're interested in learning more about this topic. If you have specific questions and you don't feel comfortable asking them in the chat, you're more than welcome to email me at cstopford@ybc.com, and I will pass those questions on to the best person. For those of you who have attended, this presentation is not accredited. However, if you would like to get a certificate of completion for your records, you can always email me and I'll be glad to provide that for you. All right, looks like we have a question here.
All right, send your questions in. We'll be glad to talk about anything that you'd like to ask.
So Titus, how do the costs and construction schedules compare to typical steel or concrete bridges?
Well, sorry, we had to go. Actually, they do compare very, very well. From a scheduling standpoint, normally our timber bridges build much quicker than traditional concrete or steel bridges. Now, the difference with a steel bridge is it's prefabricated, so that part of it can be set quicker, but our bridges do build very, very quickly. Now, in regard to cost, there's so many factors that go into the cost of a bridge, but I do want to address this. If you're comparing long free spans with our glue laminated beams, a steel bridge, probably we're going to be comparable, maybe a tad more, depending upon some certain factors. Concrete bridges, typically they're going to be double the cost. But if we can do a multiple span instead of a free span, or a repetitive span, then typically those costs are less than steel and much less than a typical concrete bridge would be.
A great question. Looks like we have another one that just came through. Is it possible to build a horizontal curved bridge in a free span or multiple span format?
Excellent question. Not with a free span, because those glue laminated beams, while they carry camber or arch, they're not made with a curve, a horizontal radius or a curve. So the answer is no on a free span. But a multiple span, yes, you can both move those bridges vertically with an arch, or you can move them horizontally. Now, in the free span portion, of a multiple span bridge, that actual span is straight. But with the approaches coming and going, then you can normally move that bridge and put a horizontal radius in the entire bridge. So yes, you certainly can do that. Good question.
Absolutely. I'll leave the floor open for any more questions for a few seconds if anyone has anything they'd like to put in. And again, we always appreciate the questions that flow through. Again, even if you've watched a previous webinar and have a question, we're always welcome, or, we always accept questions, and we're always willing to, to give you any answer that you're looking for to the best of our ability.
And I believe, Cheyenne, aren't all of the other previous webinars, they're recorded and available for people to listen to at their leisure?
Correct. So those are all on YouTube as well as our website. If you're interested and want to take a look at some of those, feel free to look at our YouTube channel. And we will also be putting this webinar out once we're done with this. So it has been recorded. So if you have a friend or someone else who's missed this, fear not, we will send this your way. All right, well, I think that is all of the questions. Again, we really appreciate you attending today's session, and we hope you have a great rest of your week. All right, thanks, Titus.
Thank you, Cheyenne.